Hey guys, it's Reed here, and this is episode 35 of Contest Coding. Today's problem is a monodirectional graph, and you can see down here this is a pretty telltale sign. If you see pairs of terms or pairs of letters, that probably means it's a graph problem. So I will put the output input like that. Okay. So first what we're going to do is we're going to read in how many lines is in each input file. So int lines equals send.next int. Then I'm going to take the start term, string start equals send.next, and string end equals send.next, like that. And then I also need to make sure I have my tree map of string tree sets data, and I'll put up here a string shortest. Yeah, let's call it shortest, that's good. And I need to reset shortest. Shortest equals empty string, and I need to set the tree set, or the tree map, data equals new tree map of string tree set string, like such. And then let's go through the lines. So at I equals 0, I is less than lines I plus plus, string s1 equals send.next, string s2 equals send.next. If not data, or actually first, tree set of string the temp equals if not data dot contains key s1. So if it doesn't have the tree set already in it, we're going to say temp equals new tree set of string, else temp equals data dot get s1, temp dot add s2. This is taking a string, putting it into my tree set, and then we'll do data dot put s1 temp. Now we're going to go and we're going to do recur through my recursive algorithm with the start, the end, and our path, which we don't know yet, and it'll just print out shortest. Now time to write the recursive algorithm. So void recur, oops, that was weird, recur, and I'm going to have string start, or actually string current, string end, and then we'll have string the path. That's taking. So first, if current dot equals the end, I'm going to add path plus equals the end, and then we're going to check and see if this solution is shorter than the other solution. So we're going to try if shortest dot split on spaces dot length is greater than path dot split on spaces dot length. And then if it is shortest, we can do the shortest. So okay, so this is if shortest dot split dot length is greater than path, that means that my shortest should be set to my path, and then I can just return out of there. Regardless of what happens, it will set it properly. Then the next thing we're going to do is we're going to do path plus equals end plus space. All right, not end, current plus space. So this is the current solution. Man, I'm making several mistakes today. This is the current location added into my path of ones I visited, and then we're going to recur through everything else, and then just temp equals data dot get current. So that's going to be my tree set that I'm going to loop through. So if temp is not equal to null, so if temp equals null, then I'm just going to return because it doesn't have anything. The reason you're doing this is because in the bidirectional graphs and things like, or monodirectional graphs and problems similar to this, you want to make sure you catch in case the data doesn't have the string, because it may be great here, it will never have anything below it. So if you loop through great, it's going to return null out of your tree map, and you're going to want to make sure you don't try to loop through a string tree map or tree set with null as the tree set. It's not going to work. So that's why we're just checking that first, and then we're going to recur through with s, the end, followed by our updated path. And hopefully that will work. I don't think there's anything else that could go fishy with this. .java, Java web, not printing anything. Oh, we have to check first if shortest is equal to equals empty string, because that's the first case. That's our null catch. So if shortest equals empty string, or shortest dot split that length, so if the shortest is greater than the current one, then it should do that. So Java C, Java, the bad, and then the bad war, and are going down the war. Yep, perfect. Thank you for watching. I hope to see you